Okay, so I will start my today's another coding practice. So here's a question. So given an integer array nums and integer k returns a number of good subarray of nums. A good array is an array where the number of different integers in that array is exactly k. Different integers in that, number of unique integers, maybe number of different integers. For example, 1, 2, 3, 1, 2 has 3 different integers. I see. Okay. So this exactly means number of unique element. Okay. So in this question, so define the interface first. So what I should return is number good subarrays. And I will be given nums and it's a k. Yeah. And I will return count. Okay. So for the date input, nums is the integer. Okay. Array, yeah. And k is number, different numbers. So if num is empty and k is also, assuming the nums can be an empty array and k is equal to larger than 0. So if ranks of nums is 0 and k is 0, probably I should return. Oh, I don't mean to implement it now. I'm just thinking of some edge cases firstly. So as the data input confirmation. So if given nums is empty and k is 0, it should return 0. Okay. But for other case, if either of them is 0, the probably I should return 0. Oh, actually it's the same. Okay. Yeah, so if either of them is 0, I can just return 0. Yeah, okay, I see. It good? Yeah. I actually don't need this. So anyway, and so the data input, everything's clear, so let me think with some examples. So if given nums is let me think of this case. So I see. Yeah. Okay, let me do this. Okay, so firstly for this, because case 3, this isn't good. And for if I expanded this isn't good because it has only 2 different numbers. But this one, this is good. And if I expand this, so if I expand this anymore, it can be good. However, here 1, 2, 3, 2, this is good. But when it reaches 1, 2, 3, 4, until 4, this isn't good. Okay, I see. Okay, let me think of this with right edge, yeah, fixed. So if I fix this, here, this isn't good. So if I shrink this number, if I shrink this, all of them should be not good. But here, 1, 2, 3, this reaches good. But if I shrink this by 1, this becomes bad. And obviously, so 2 to 3 is also bad. It can't be good anymore. Okay, then think of the case when it is 2. Here, this is not good. This is good. Then if I shrink this by 1, like this, 2, 3, 2, this isn't good anymore. And after that, all of them are bad. So I will fix the last ones with 4. If I fix it in this way, it should be not good. Yeah, because I have 1, 2, 3, 4. Then if I if I delete 1, now this becomes good. Yeah. And after that, good condition continues. Yeah. However, if I pop out 3, this becomes bad. Okay. So one observation I can make from here is that firstly, it can be good or bad. And if I pop it out, okay, think of the case by case 3. And if firstly the array has 4 or more distinct numbers, it begins from bad as subarray. And after that, if I pop it out, it becomes good at some point because distinct numbers, unique numbers, I mean, different numbers can be 3. Then after, if I keep popping out, it becomes 2. And at that moment, and after that, array is always bad. Yeah, I'm talking about the case when right edge is fixed. And think of how left is moving backward, moving forward. Yeah. And if the number of distinct numbers begins from 3, for 3 it is good, but if I keep shrinking, it becomes bad at some point. Then after that, all of them are bad. And if I begin from subarray who has only 2 or 1 or 0, I mean 1 or 2 distinct numbers, it begins from bad, then all of them are bad after that. Yeah. So that being said, yeah. I see. Okay, so probably the brute force approach I can take is um triplet or I mean cubed n and cubed because I pick up left and right each combination, and for each combination I will traverse those numbers and confirm if they're different, how many different numbers are there. Yeah. but I wanna speed it up. So okay. So obviously first in line 21, it begins from but, which is smaller but. So because this is smaller but, I have to think of incrementing it. Yeah. So I'm thinking we're using sliding window. So what I mean is I just keep incrementing right. So when it reaches good, it is possible that I can shrink it. So if I shrink it, it can become redstone or equal to 3. Okay. So in line 45, array has 1 to 3, which has 3 different numbers. And then I have an option that I move the left pointer to decrement the count. But also I have an option that I don't decrement and increase. Okay, let me think with some easy case. So if I celebrate 1 to 3, first 3, left reaches, right reaches number 3. Okay, sorry, let me do index 2, and left is 0, index 0. At this moment, if I move the left pointer, this becomes less. So I don't want to move it. However, okay, so let me think with this. So at this moment, the only option I can make is move the, yeah, right pointer. Then I have an option that I decrement the left pointer. Yeah, yeah. However, if the next number is 2, I also have an option that I keep this 0 and I increment this. Or I see, I keep from line 60, I increment this. So I think I cannot decide I should move the left pointer or not in at line 59. As long as the number different values, different numbers doesn't change, it is okay to shrink or not. K is 3. When K is 3, 0, 1 to 2 is okay, but 1 to 2, wait, 1 to 2 isn't okay. Hmm? What do you mean? Sure, this isn't okay. No, this is okay, but this is not okay. Okay, so let me think this case. So here I will increment this 2. So okay, so now I have an option to remove it. But even if I don't remove it, it doesn't change. I see, okay. So as long as the same number continues in a row, it doesn't matter if I shrink it or not, because it doesn't change the number of the same numbers. Okay, so I've come up with a solution. So I probably what I can do is, if numbers are in a row, I should compress it to one element, because numbers in a row doesn't change the number of different numbers. Yeah, okay. So in this case, I should convert it to number 0, which has 2 elements. Then I have 1, which is 1 element, 2, which has 3 elements. Okay, so from here, I will use the kind of, yeah, so sliding window. Because I try to get, wait a minute, so if I try to get case 3, number of different numbers 3, okay. So with this being said, this is the only option. And assuming that I have another number here, we're missing this. So if I get this, I remove the right pointer, and I find that the number distinct element is Roger, so I will move this. Yeah. Okay. And what I should do next, so yeah. Okay. So things become interesting when I move the right pointer, I guess. So here, 1, 2, 3, 4. Oh, so sorry. So actually here, I don't have to shrink this, because this still has 1, 2, 3, 2. So which is only 3 numbers. Then we're missing that I got 4, 5 or something. Yeah. So if I get this, I should, with left pointer fixed, if I shrink this, now it has 4 elements. I have to shrink this in this way. And now it has 2, 3, 2, 4. Okay, so it's good. So if by compressing numbers into number count, adjacent numbers are unique. So I mean, what I mean to say is, I, with the right fixed, I have only one choice of left pointer, where the left pointer should be. So with right pointer at 2, 3, I mean the index third element, the right has to be 0, 2 here. Same with right pointer at the fourth element, left pointer must be at the second element. Okay. Yeah, I think so. So with that being said, how many subarrays are there in each, um, window, compressed window. So in this case, it should be like this, 2, 3. So here, I have two choices on the left from 0, first 0%, 0. So now it should be 2 times 3. Okay. Yeah. So basically I multiply count 1 and count 2, count left and count right. Then I will add all of them. Okay. So this is algorithm. So let me think of the time complexity. So firstly, for compression, it will take n time, assuming that n is the number of element in the nums. And also for 2 pointers. So because right pointer moves from 0 to end of the index, which takes exactly n steps. And for left pointer, it takes n steps. So in total, it should be n plus n is 2n. The thing here is not that it shouldn't be n by n, because I don't take any combination of left and right. What I'm doing is independently move left and right. So yeah, just think that I move left or right forward one time in one step. Max number of steps is, number of steps is move left from 1 to n plus move 0 right from 0 to n. So it should be 2 times n. Yeah. Okay, so that being said, writing the logic. And also for counting numbers, it takes constant time because, yeah, so it should be O of n. Okay, good. So I will use this as a test case. So what's I will think of 2. So yeah, let me think with 3. Maybe. So with this, I should, because if the distinct number, unique number is 0, 1, 2, it should have 2 times 3 options. Also for 1, 2, 3, it should have 1 times 2. And also, yeah. Oh, I try to quickly check the case when this number duplicates, so like this. In this case, 0, 1, 0. Wait, in this case, 0, 1 is possible. Also 0, 1, 0 is possible. So first three when case 0, 0, 0, 1. And also 0, 1, 0. Same, and also 0, 1, 0, 2 isn't valid, and for 1, 0 and 0, 2, yeah, both of them should be 2 times 2. So this is expected numbers. However, as I said, so this isn't covered in my case because I was thinking, I see. So probably I need to update the case of how the spreading window moves. Yeah, so I'm missing with this. So in this case, first I will start with this, okay? And then moves the left pointer, it's okay. And then I move the left pointer, it's okay. And I have an option that I shrink it and not. So one thing I can say is, it doesn't matter if I shrink or not, here and here, 0 and 1. I mean, if I pop out 0, left mod 0 and not, doesn't matter. As long as I have 0 in the window. So so what should I do? In this case, I try to guess every left and right combination, which has exactly k distinct numbers. Yeah. Wait, but my what I'm wondering is, at rank 85 with right index 0 fixed, I have two options. But after that, if I have another element, like 2, okay. Yeah, this of them works. So what happens if I have another number 2? In this case, I have to pop out 0 and 1. So it must be like this. Okay, I see. So what I can do say is if I have the duplicate numbers in the window, it's okay as long as, yeah, I see. So as long as the number of element is less equal to k. However, once the number of element is more than k, I have to pop out every element, duplicated ones. So, yeah, I have an idea of how I can do it. So here at line 85, I found that this is valid, and even if I move it, it also valid. So here, keep moving left until it is valid. Yeah. Then say if all of them are 2, the count left should be 2 plus 2 is 4 now. Yeah. So for next, as long as this is yeah. So theoretically this has 4, and this should be 2, and this should be 8. However, and since that I've got 0 again, oh, in that case, because this is no, yeah. And if since that if I got 1 again, hmm, yeah, hmm, yeah. Okay, so I will move left until it is buried, and then multiply 4 times 2. This makes sense, and this is possible as long as I have the counter. Yeah. So here, this should be 0, 0. Here, this should be 0, 0, and 0, 0, 1, and 0, 1, 1, 1. And then I've got 0, 1, 1, 0, 2, 1, 1. Because they're multiple element, I can shrink it. I can check if I remove decrement 0, 2 to 0, 1, it is postponed done. It's okay. I can shrink it. Okay. But if I shrink it one more time, this becomes invalid. So I can't shrink it anymore. Then when I get 1, okay, I will keep shrinking. So first, okay, so first we get 0, 1, 1, 2. Then if I shrink it again, no, 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 no. Wait a minute. So O2 is okay. Why did I move the right pointer? I just moved the right pointer and 1, 0, 1. This is okay. And I still have 4 here. Yeah. And I noticed that I can shrink it. Actually, yeah. So if I shrink it, possible. And now this becomes 6. So it becomes 0, 1, 1, 1. And I can't shrink it anymore. So this should be 6. However, if I get 2, so this is updated to, to 1. So this is more than k. I have to move this left pointer until it becomes, yeah, move left pointer until the size becomes less than k. And the thing is, in this case, this should be, oh, wait. So this is invalid. Yeah, and because this is invalid and string, so this should be reset to say 2 or something. Then it should be 2. Okay, so that's a basic algorithm I can use. So for which window, as long as I can move the left window, I shrink it and increment the number count of that number count pair which is popped out. And I keep that number as the count left. And if the number of elements, yeah. Also, if I add the new number at the right index, and if it becomes more than k distinct numbers, I will move the left pointer. In that case, I don't increment the left. I mean, left count will be reset with the new position num count pairs count. Okay, so let me write the pseudocode. I will move each right, and then what matters is left count. Yeah, I should begin with and compares index. Yeah, count, which is actually the first index, and move it. So, oh, should do. Okay, if distinct number is more than k, move left here, and also left count should be the num count at that index. However, as I said, and I will continue. If distinct number is k, what do you mean? Move left while this condition is met, and for while that, I will increment it. Yeah, this is the key. And if k is smaller than this, what happens? I will just have to move the right index so that I can find, yeah, I have to add more distinct numbers. Okay, so then here, yeah, this is the same. Okay, so let me work on the implementation. So first thing what I should do is I will compress it. I can do it. If series number and first numbers num is equal to current num, I will just increment the count. Otherwise, so num and count one. Okay, so first three compress. So the next thing I will do is I will start with ref count. Oh, sorry. Yeah, and ref begins from 0. And yeah, this is the return number. So as I said, if okay, and I need the counter property. Means oh, see, so I have to do quickly returns edge case. Okay, then I will move the right counter, so it begins from 0, 0. So yeah, okay. So if this is a distinct numbers, this is smaller than k, I will just continue. Yeah. Oh, no. So, but before that, what I should do is, because right number is added here, I will right number. Num count. This is index. So in counter, I will increment it. Oh, right count here doesn't matter because this counter does compress num count. Okay, So ranks counter is less than k. I will continue to append more number, right numbers. Okay. So, and then if this is exactly k, if when it reaches k, I will move the left pointers. So what I'm interested in is I will write this to the code. So while yeah, and as I said, new left index counter. Yeah, okay. Then I will append this to total count. Okay, so I can do, yeah. Then I will continue. Otherwise, oh, so what we can do just like this. If number, yeah, this is Roger. I have to pop out the left number. And it guarantees this. Wait, so the problem I think here is if number is 1, 1, 1, 2, and if I'm looking for case 2, okay, yeah. In this case, left, right pointers move until here, and after that, okay, so the thing is, even though there is a duplicate, I see. So at this moment, okay, 1, 2, 3, and I will start counting. So if k is smaller than length counter, it means that I need to shrink. Okay. If this is Roger, I will move the left index. Yeah. So at this moment, Let's see. This is K. The probably I think. Okay, I see. So I can do it in this way. Firstly, if number of count in the window is more than K, I will shrink it as much as possible. And at the moment there's the same, I will start shrinking it. Yeah. Wait a minute, so what is K and count? So I see, okay. I think what I can do is, firstly, I will shrink. Yeah, the left index until, range of the counter is K. Then I will shrink it again until it is K. And I will update left index with the same number. Yeah. Okay, so this one should be just counter. Okay, so the first thing I need to do is, if the number element is a counter, if unique number is larger than K, I will shrink the left index. I will shrink the window by moving the left index. And at the moment if the count 0x3K element, I will shrink left as much as possible. Yeah. Then I will, yeah, update the rough count, and yeah, after that I will update total count. Okay. And if when I'm shrinking in line 133, I will update it. Just update it. However, in line 140, left count should be added, incremented. Okay. Yeah. Actually, in 133, I think this happens only once, because in 138, the window left is shrink as much as possible. And the thing is, after this while loop, it turns out that if I move the left pointer even one index, it reduces the number of number of distinct numbers in the window. And probably this window doesn't have more than K plus 1. Yeah, never mind. I think. But it's okay, yeah. I can even use the while loop. One thing I have to do is counter up to remover. I remove this. Mm. Counter. Oh, actually, I shouldn't do it with me, so I see. So counter, sorry, this should be counter to 'If this is 1, I should decrement current count. Yeah. Yep. So let me run this code. I'm a bit tired to too tired to do the walkthrough. 121. One, 121. Ah, okay, sorry. So 122. Ah, okay. So I can't assign tuple. I can't update element in tuple, so I will update it. So in 140, I guess. Okay. I don't need ranks because I just returned. Yep. 137 left count. Hmm. I see. So left index. So finally it reaches, yeah. So left index, the range of left index is from 0 to length of nums, num counts. Hmm? Yeah. Okay. How can I handle it? Let me print it out. So in the case of 130, so with this case, this should be compressed into, okay, this one, and it's start from, oh, sorry, left index, and let me change it. Okay, so it begins from 0, 0. Oh, k is now 3. Okay, so 0, 0, and it goes to 0, 1, then 0, 2. So where is okay, and it goes to 1, 3. So it goes to 0, 3 and shrink to 1, 3. Then what happens is that from 1, 3, hmm? Oh wait, I forgot something. So in 144, when left index is moved, I should update the counter. So yeah, this is one thing I have to do. Wait, left num. So this is like the hell. So, okay, what we do is quickly. So nums left 0, so this number should be. Wait, so when 0, 1, right, range 0, 1, 0, 2, this is wrong. So probably in 137, right now, right count, num count, right index. Hmm. Oh, I see. So wait a minute. So here, I don't have to add this in 129 because I try to add the first one, but actually, because first index is added when right index is 0, so I don't need it. Okay, So that makes sense. 0, 2. So in 141, left count. Ah, okay. I have to do it before updating left index. Then in 140. Length of the counter is 3. K is 3. Oh, why is it? So K is 3 and length of the counter is also 3. No, 4. So yeah, left index is append added by 1. Left count number. Wait, counter is not updated here then. Ah, then left count is okay with this. Okay, good. So it is passed. So I will try with another test case. Oh, good. Okay. So I will read this. It runs. And I will run this on the LeetCode. Okay, I got wrong answer. Okay, so I will first confirm the num count array is correct. 2, 1, 1, 3, 2, 1. Okay. So then as I did, I print it out here. So firstly begin with 0, 0. Okay. I see. So the problem is here in line 39, I guess. So if left and right are the same, yeah, I probably what I should do. So there are 5 numbers, and yeah, I should get 5C2 number combinations. I pick two numbers from, yeah, left count is equal to right count. Yeah, so okay. Yeah, so this is the thing. Wait a minute, left count. Left count. Yeah. Ah, okay. Also, yeah, okay. So it is 1 and 3 is 1. Makes sense. If this is 1, oh, it should have 1 number. Okay. Okay. So I get 1, 3, 1. And for 3, how many? When so because K is 1, left and right. So wait, so if the ranks is 3, is the rank okay, the problem here is how many subarrays I can take from the ranks of say 1 or 3 or 1. Okay, so the last thing I have to think is this part in. So if there is only one element, number of subarray is 1. Is there 2 element, number of subarray is 1 to 3? And if there's 3 element, yeah. So in this case, number of subarray is total subarray is so 2, 1, 2, 3. 3 plus 2 plus 1. If I choose 1 as the left index, I have, oh, sorry, 4 choices. And if I choose 2 as the leftmost index, I have 3 choices. I put 2, 1. So basically this should be so length plus 1 times length by 2. Okay, good. So let me run this code. Let me submit it. It's good. So finally I can solve it. I don't know how much time I used for this question, but this is a hard question and I could finally solve it by myself with the same answers. So I think it was good in a sense. Okay, so let me finish my coding practice. Okay, thank you so much. Bye.